Hello, my name is Carlos Alonso Ramos. I'm the coordinator of the SYMPHONY project. In this research project, we aim to fill a technological gap, which is the lack of a technology providing analysis of gas concentration and presence in the atmosphere with a device, with an approach that is compact, robust, low cost, and easy to use. So to address this challenge, we choose to make a combination between silicon photonics and AI. Silicon photonics mainly because it provides the capability to make large volume production of compact and low cost devices, and AI because it's a very powerful tool to improve the performance of our devices, allowing smart analysis of the gas that we are analyzing.
Current existing sensor solutions are either very expensive, requiring a lot of maintenance, or low-cost solutions showing cross-sensitivity to other gases and have a very reduced lifetime span. In SYMPHONY, we try to overcome these obstacles by addressing optical sensing solutions and combine this with photonic elements in order to realize a compact, small, large-scale deployable sensor system. In SYMPHONY, we are not targeting high-performance, high-resolution instruments. Instead, we are trying to realize small miniaturized gas sensors for realizing sensor deployment for ubiquitous networks.
Spectroscopy is a powerful technique to figure out what chemicals we have in an unknown sample. It is based on the insight that white light, for example, sunlight, is a combination of multiple colors, and that different chemicals absorb different colors. For example, carbon dioxide absorbs certain wavelengths in the mid-infrared region very strongly. And by looking at which colors are missing from this white light, we can know which chemicals the light has passed through. Thus, we call the method optical absorption spectroscopy.
So in SYMPHONY project, we measure the suspending waveguide, also our photonic gas sensor at KTH using our in-house measurement setup. By doing that, we get first-hand information about the device performance and also the gas sensing performance. And that is beneficial for us to implement the sensor on site, like for methane sensing for the biogas production, and also the CO2 sensing for the air quality monitoring.
So, in SYMPHONY project, we focus on the detection of carbon dioxide and methane, both gases that have their absorption spectrum within the mid-infrared range. In order to fully exploit the silicon platform, we need to get rid of the silica underlayer. This is because this absorbs after 3.2 micrometers. One way of doing this is to use suspended structures like the ones showing here. These structures are based in a subwavelength grating cladding, which allow us to confine and guide the light.
A key technology behind these suspended waveguides is a wavelength grating technology. This technology allows us to guide the light into the chip by using a periodic arrangement of segments and gaps. However, these features are so small that light cannot resolve them, and instead of seeing them individually, the light sees an effective material. This effective material has optical properties based on the geometry of this periodic pattern. For example, based on the width of the segments, the length, or the periodicity. Every integrated circuit is made of a set of basic components or building blocks that perform basic operations. These operations are, for example, dividing the light into different branches using power splitters, combine it again using combiners, making it go slower, or make it interfere after that by using interferometers, or even deconfine it. How well these operations are performed and how well these building blocks are designed has a very strong impact on the performance of the final application and the final system. By using sub-wavelength grating technology, we can choose the optical properties of this effective material that we will use at the end to design our building blocks. This means much better performance, not only at the component level, but also at the system level. So this means much lower losses, much better power consumption, or, for example, in our case, much better sensing capabilities.
For gas detection, enables artificial intelligence models to run directly on sensors in order to identify gases on the environment based on their absorption. This allows faster and more energy efficient gas detection, suitable for use in remote, distributed or resource-constrained conditions. However, this can be challenging for two main reasons. First, real sensors are never perfect. Introducing noise sources like fabrication imperfections, background noises, or changes on the temperature that can cause errors during measurements. And furthermore, different gases may have similar absorption features. So in multi-gas scenarios, we have different gases that may have similar absorption features, and this can be challenging for gas detection. For this reason, when we use AI models, we can reduce the effects of this phenomena, leading to more stable and robust gas detection. In order to train our deep learning models, we use scientific databases such as Hydran in order to simulate realistic and challenging environmental conditions.
Hello, I'm Thomas Dory, the CEO of BERT Energy. We have been building biogas plants for the last 16 years, and we are interested in SYMPHONY in the two applications, which is process optimization, which is important for us to get the maximum methane out of the plant, and also the leak detection, because leak detection is not only a pollution, but it's also a loss in profitability of the plants. Therefore, we are very happy to be part of this program.
So SYMPHONY is a highly interdisciplinary project involving partners with different scientific and industrial expertise. We are working on bridging the gap between analog computing and machine learning algorithms. Such co-design approach targets in increased efficient edge devices that allows us to collect, proceed, process, and transfer sensoring data and processing in a distributed manner.
In the SYMPHONY project, we work people from a lot of domains. I, for example, am a person from the systems and programmation area. Therefore, my paper in the project is to design and make the different layouts that we are going to put on top of the chips. Right now, I'm working in one device that their function is to couple the light from the source into the chip and be able to feed the different devices that are going to be inside.
Hope you have a great introduction to the SYMPHONY project.
SYMPHONY runs until 2027, and all updates will be on the website.
So please free to stay tuned. Also, follow us in the different conferences and papers we have coming.
You can join to our LinkedIn group using the QR on the screen.